Hi friends, this is Rashekar, a GATE faculty for electrical machines. Today in this video we are going to differentiate between power transformer and distribution transformer. What are the difference between power transformer and distribution transformer? Let's see. Generally we know that power transformer used at power circuits are simply these are used at transmission and generation. Power transformers are used at transmission and generation. What about distribution transformers? Distribution transformers are used at distribution networks. We are using at distribution networks. Generally, these are high rating transformers, but these are in generally low rating transformers. These are used for high voltage applications greater than 33 kV, but these are used for low voltage applications less than 33 kV. High rating, low rating, high voltage, low voltage applications. And generally power transformer load fluctuations are very less, but on distribution transformer load fluctuations are more. Load fluctuations are less, load fluctuations are more on distribution transformer. And next one, in generally for same rating, this is lesser in size. This is more size. In size point of view, for same rating, this is less in size, but this is more in size. Other than this, in power transformer, the secondary winding may be star or delta, no problem. But in distribution winding, the secondary winding should be star connected in order to make a neutral grounding. In distribution side, we must and should need a neutral grounding. That's why the secondary winding should be star connected. And next one, generally here power transformer 24 hours input and outputs are constant. 24 hours input and outputs are constant. But in distribution transformer 24 hours input constant, but output depends on load cycle. 24 hours input constant, but output depends on load cycle. Yes or no? Here 24 hours input and output is constant, but here output not constant. Early morning very high output, afternoon slow, normal output. Again evening 3 to 4, 4 to 5, no output on the transformer, no load on the transformer. Again evening 6 to 10, high load on the transformer. Like that, 24 hours input constant, but output depends on load cycle. output depends on load cycle. So that's why here fluctuations are less, here fluctuations are more. That's why fluctuations are less, fluctuations are more. And here during the manufacturing, it should be less copper losses. It should be less copper losses. During the manufacturing, the copper losses should be less. Here, during the manufacturing, less iron losses. We should take care, less iron losses. We should manufacture the transformer with less iron losses. We should manufacture the power transformer with as minimum copper losses. Next one, here core made up of CRGO silicon steel laminations. But here core made up of amorphous steel in order to control the iron losses. Here the core made up of amorphous steel. But here in generally the core made up of silicon steel. Sir, if power transformer core made up of amorphous steel, then what is the problem, sir? Generally the amorphous steel withstand up to 33 kV only. Its brittleness is very high. Amorphous steel brittleness is very high. This is capable up to 33 kV only. If for power transformer, if you use amorphous steel, then it gets breakdown, because here the voltages are greater than 33 kV. That's why don't use amorphous steel for power transformers. Are you okay? Right? So next here, transmission and generation and distribution, high rating applications, low rating applications. For high voltage applications, low voltage applications, load fluctuations less because 24 hours input and output constant. Load fluctuations more because output depends on load cycle. Here secondary winding may be star or delta, but it's a secondary winding maybe. It should be star in order to connect the neutral grounding. And during the manufacturation, we should take care of copper losses. Copper losses should be minimum. Here iron losses should be minimum. That's why here the core made up of silicon steel, here core made up of amorphous steel. And next one, generally in power transformer, the output or efficiency depends on input and output only. Efficiency depends on input and output only. But in distribution transformer, efficiency depends on load cycle especially. Input and output. This is important. Load cycle, input and output. There is no need of load cycle, but here load cycle, input and output. And next one, in distribution transformer, efficiency is equals to output in kilowatt hours upon input in kilowatt hours for 24 hours, within 24 hours. This is efficiency of distribution transformer. But the efficiency of power transformer is equals to output in kilowatts upon input in kilowatts. Simply output in kilowatts upon input in kilowatts. This is the main difference between power transformer and distribution transformer. Here the power transformer efficiency is called power efficiency, but distribution transformer efficiency is called energy efficiency. And power transformer efficiency is called commercial efficiency. And this efficiency is called all day efficiency. all day efficiency. All day efficiency or energy efficiency. This is power efficiency or commercial efficiency. Commercial efficiency. This is about the power transformer and distribution transformer. Now the last question. At what load we can get the maximum efficiency in power transformers? In power transformers, at nearly full load, we can get the maximum efficiency. At nearly full load, we can get the maximum efficiency. But in distribution transformer, at 50% of load, maximum efficiency takes place. Maximum efficiency occurs at 50% of load. Maximum efficiency occurs at 50% of load. Nothing but here at full load maximum efficiency occurs nothing but copper losses is equals to iron losses at maximum efficiency. But here at 50% of load, nothing but 1/4 times of the copper losses is equals to iron losses. Yes or no? 50% nothing but 1/2. At 50% of load, what is the copper losses? 1/2 whole square, nothing but 1/4 copper losses. So iron losses is equals to, that's why I said you less iron losses. It should be, the manufacturing should be with less iron losses. Iron losses should be equals to 1/4 of the copper losses. But here copper loss equals to iron losses. That's why if the copper losses are less, we can get the maximum efficiency. These are the differences between the power transformer and the distribution transformer. Right? Are you okay? So for same rating, I given you already. For same rating, this is lesser in size, but this is more in size. And last one, generally here it is called power efficiency and it is called all day efficiency. Always the power efficiency is greater than the all day efficiency for same rating. Always for same rating, the power efficiency is greater than the all day efficiency. This is final point, very important. These are the difference between power transformer and the distribution transformer. Are you okay? Right? Thank you, sir.